Okay. Okay, so today we're going to go over horizontal asymptotes. Okay? So this would be now the limit as x tends towards infinity of f of x. Okay. So when you talk about a horizontal asymptote, you're asking about what is the behavior as x tends towards infinity. So one of the more basic ones we'll deal with, and this is just a rule that you need to know, okay? The limit as x tends towards infinity of 1 divided by x is going to equal 0, and the limit as x tends towards negative infinity of 1 divided by x is also going to equal 0. So, what is this problem really stating? Okay. So, as x tends towards infinity of 1 divided by x, it is going to tend towards 0, okay? So that is a horizontal asymptote. So that's the behavior as you go to an infinity. This thing also has a vertical asymptote, okay? A vertical asymptote are points where it's going to go to plus infinity or minus infinity. So that's the difference between vertical and horizontal. Horizontal is asking about the ultimate behavior as x tends towards infinity, okay? So. But does this thing have to go to 0? No. Well, this one does. But we have different horizontal asymptotes that will approach different points. Okay. They can also approach infinity. Your horizontal asymptote can be infinity. Your different you can also have slant asymptotes. They'll tend towards infinity, but we'll eventually end up going towards the line. We'll kind of skip over that in this lesson. It's something I do for more advanced calculus stuff, like the honors calculus class. So, although some people might not agree with that. Okay. So let's say we had something like this. Okay. Now, if I actually draw the picture of this thing, what does it look like? This is going to be 0 right here, and the 1, 2, 3, 4. Okay, this is going to be my asymptote. Okay. Now, the bottom of this, remember you can't divide by 0. So x squared minus 2x plus 1, that's really, it's the same thing as saying x minus 1 squared. So there's going to be a vertical asymptote at x which equals 1. And so this thing ends up looking like this. So this guy comes down, so it hits right there, and comes back up. Goes in that direction, and then on the other side of the vertical asymptote would be going in that direction. So that's going up like that, and that's going up like that. So x which equals 1. This is the vertical asymptote of this problem. Okay, so that means it's going vertically. But if I ask the question about, well, if I'm headed towards negative infinity or positive infinity, this thing is actually going to tend towards 4. Okay, but I'm not going to expect. First of all, you should not be having graphing calculators whenever you're doing this. But I wouldn't expect you to be able. I mean, wow. With enough push, you should be able to graph this thing. But I'm not going to ask that on the test. Okay? So how would we justify that the limit of this thing is actually going to tend towards 4 as we're tending towards infinity? Okay. Okay, so this is the problem we're looking at. Let's say, what is the limit as x tends towards infinity of 4x squared plus 2x minus 1 divided by x squared minus 2x and then plus 1. Okay, you'll learn L'Hopital's rule in the next chapter. We'll have that on the next test. Remember correctly. But we don't necessarily have to have L'Hopital's rule to deal with a problem like this. Okay? So whenever you have a problem like this, what you're going to do is you're going to divide by the highest power. Right? So we're going to take the top and the bottom. We're going to say, okay, what if I divided by x squared and I divided by x squared? Okay? And we're tending towards infinity, so we're not going to worry about the fact that there would be a singularity at 0. Okay. That's going to equal the limit as x tends towards infinity. That's going to be 4 plus 2 divided by x minus 1 divided by x squared. Right? Divided by 1 minus 2 divided by x plus now 1 divided by x squared. Right? So that would be 4 plus 0 minus 0 divided by 1 minus 0 plus 0. Okay? So all of that would come out to being 4. Okay? So you all saw in the previous problem that the limit as x tends towards infinity of 1 divided by x, it goes to 0. Okay? So if you have a constant that is going to be divided by infinity, it's going to go to 0. So the whole reason of dividing by the highest power is to make all those other terms go to 0. Okay? So this goes to 4. Let's try another one. So let's say we have the limit as x tends towards infinity of 2x cubed plus x minus 1 divided by 3x cubed plus x squared plus 1. Okay? So the third power is the highest power on this thing. So that's what we're going to divide by. So that's going to equal the limit as x tends towards infinity of 2 plus 1 divided by x squared minus 1 divided by x cubed divided by 3 plus 1 divided by x plus 1 divided by x squared plus 1 divided by x cubed. Now it's not necessary for you to write out this is 2 plus 0 minus 0 divided by 3 plus 0 plus 0 plus 0. All of these terms are going to go to 0. So at this point in the problem, you just say, you know what, this is 2 divided by 3. So whenever you have the polynomial on top and the polynomial on bottom have the same degree, well, then it's going to go to the leading coefficients. Okay? Let's consider a problem where we don't have the same power on top and on bottom. So let's say we're dealing with the limit as x tends towards infinity of okay. Now, on this problem, it doesn't matter if you divide by the highest power on top or the highest power on bottom, but I'm just going to tell y'all at this point, whenever there's a higher power on top, it's easier to divide by the highest power on bottom. So in this case right now, let's just divide by the highest power on bottom and see what we get. That would be 1 divided by x plus 2 divided by x squared plus now 1 divided by x cubed divided by 1 plus, still on the screen yet, 3 divided by x squared plus 1 divided by x cubed. Okay. So this would become 0 plus 0 plus 0 divided by 1 plus 0 plus 0. Okay, so that's really 0 divided by 1, just comes out to be 0. Well, okay, so if the polynomial on the bottom part of this problem has the higher degree, then it's going to go to 0. Okay. What if the polynomial is the higher degree is on top, though? Let's say we have the limit as x tends towards infinity of, let's say, x cubed plus 2x squared plus 1. And now divided by x squared plus x plus 1. Okay. On this problem, once again, you can divide by the highest power on top or bottom, but it's easier to divide by the highest power on bottom, because if you divide by the highest power on top, what are you going to get? You're going to get 1 divided by 0, and you have to justify that that's going to infinity. But if you divide by the highest power on bottom, let's see what happens in that case. Okay. So that would be the limit. Now as x tends towards infinity. Okay, so x cubed divided by x squared is just x. 2x squared divided by x squared is just 2. And that becomes 1 divided by x squared. Now that's 1 plus 1 divided by x plus 1 divided by x squared. Okay. Well, that goes to 0, that goes to 0, that goes to 0. And that's going to be the limit as x tends towards infinity of x plus 2. Well, at that point, you can just say, you know what, that's going to tend towards infinity. Because infinity plus 2 is just infinity. Okay. So this is the different type of rational polynomial involved functions that you can get to, and you can guarantee there's going to be at least one of these on the test. So Normally, during if this was a face-to-face class, I would say you need to fully justify all of these steps to get to the answer. But since it's going to be a multiple choice test, what you can know is if you have the same power on top and bottom, it goes to the leading coefficients. If you have a higher power on bottom, it's going to go to 0. If you have a higher power on top, in that case, it's going to infinity. Okay?